Well, hello everyone. How you guys doing? It has been an unbelievably long time since I streamed. Last time I streamed was the 26th of November, and a lot has happened since then. So where have I been? Where have I been? What have I been up to? Um, and what's going on in this project and this channel? Um, well, let's see. 26th of November was the last time I streamed. Um, After that, I was swamped with work. I had a lot of work um that I had to do at the very end of the year. And my contract ended at my full-time job. So I had to find a new job, and I took like a 2 weeks break, just to mentally kind of, um, just just mentally decompress and kind of relax. I haven't taken a break since COVID started, so about 2 years. Hi Kareem. I'm good. How are you doing? Hope you're doing well. Welcome to the stream. Um, and so I took kind of 2 weeks break. It was good. I learned a bunch of new stuff. I learned Python. Um, I was learning assembly, x86 assembly. And I was kind of learning how to create an operating system from scratch. It's kind of interesting, and I kind of want to pursue that. And eventually, I would love to teach you guys that. So I managed to create in 2015. Yeah, I created my own game engine with OpenGL DirectX and C++. And then I made a game on top of that, and now I'm making an operating system. So we're gonna make an operating system that has a game engine on top of it that runs a game. That's the only purpose of the operating system will be, which will be pretty cool. But yeah, so been learning how to do x86 assembly and learning about operating systems and how they work. They're really fascinating, so I'm trying to get more into that. Um, and I've been learning Python, and Django, and a bunch of backend technologies. It's been fun and kind of relaxing 2 weeks. And then I found a new job. I had a bunch of interviews that I had to do. I was busy with that, and then I got the flu. The flu was a motherfucker. Um, Thankfully it wasn't COVID. I got tested. I went to took a PCR test. It wasn't COVID. It was just the flu. It knocked my ass off, man. Um, I was in bed for like a full week. Couldn't get out of bed. Um, I had a fever. I was coughing. It was a whole disaster. So it got better from that. Thankfully. Um, and yeah. Here I am. I still have a little bit of a cough. But all in all, pretty well. Doing pretty well. I want you to focus more on engine architecture and design after finishing being stuff. Yeah, I would love to do that. That's something I'm really, really interested in, and I will definitely do that. After the series is over, we'll definitely do engine architecture and kind of do more advanced stuff like OpenGL stuff, DirectX, Vulkan stuff, shaders, things like that. Even in this game, we're gonna do shaders in this game. It'll be pretty cool. No problems, architecture and the engineering of the engine. Yeah, that's a that's a pretty big problem. On how to kind of make your engine as optimized as possible and run as fast as possible. With your whole entity component systems, ECS, if you want to implement that on top. So yeah, I mean rendering a triangle on the screen or rendering a bunch of meshes, that's no problem. But rendering thousands or millions even, um, that would be an issue. So a while back, again around 2017, when I was building my engine, I had a goal of rendering 1 million entities on the screen. And I managed to do that at 60 frames, which was fascinating. It was so cool. Um, I had to basically rewrite the entire engine again to kind of manage to do that, which was pretty cool, but took a while. What else have I been doing? Yeah, I've been playing Final Fantasy 13, again from scratch, um, all over again. I never managed to finish the game. I got very close to finishing it, but never did. So I restarted the entire thing. A really good game. I really like it. Um, haven't been really playing a lot of video games except Final Fantasy 13. Kind of finishing that off and just been learning a lot of stuff. And yeah, just waiting on signing a new contract for a new job. It's a very good job, thankfully. And yeah, I was in that period also I was looking for an apartment to move out to. Went apartment hunting, which was fun. It wasn't fun. But yeah, found a bunch of apartments and haven't yet moved out. Hopefully soon. But yeah. So that was pretty much the entire 2 months that I was absent or disappeared. 2 months? It's been 3 months. Holy shit, it's been 3 months. Almost 3 months. But yeah. Anyways, the point is, use instancing or batching. I used batching. I tried not to use instancing when I wanted to render the 1 million entities. Um, just because I wanted more control over the entities that I'm trying to render. Because with instancing, basically all the entities are the same. You just give them different textures or different colors and so on and so forth. Um, so yeah, but no, I managed to render 1 million unique entities without instancing. So just a bunch of batching stuff, which was pretty cool. Anywho, it was I was trying to do that in 2D, so it was I had a 2D game in mind, and I managed to do that. So if I can render 1 million entities without like occlusion culling or any kind of optimization, um, imagine how many entities you can render. Well, on screen it'll be just 1 million entities. You'll just have 1 million entities on screen, but off screen you can have a lot more, which is kind of cool. Anywho, uh, cool. Now that we're here, um, let's uh, let's jump into this and kind of cover what we've been doing so far. All right. So last time we did this, we created our lookup table. Well, um, not to forget the whole going insane over trying to figure out how big the stack is. So apparently the stack can grow on x64 systems in release mode. I did not know that. And I'm still not completely sure about that information, but the stack apparently can grow. Um, so we created our lookup table. We essentially said that here, where were we? Grab this. Let me go to assets folder. World was it? Yeah. So we went through this entire texture, right? And we've numbered every single tile with a unique ID, right? And that's our lookup table. And essentially what we're doing is saying, hey, since every single tile has a specific ID or a specific number, what I'm going to do now is tell the engine or tell my renderer that I would like to render this tile, this tile, this tile, and this tile, right? And each tile has an ID. And so that's what we're doing, right? We're specifically telling the engine, hey, I want to take these tile IDs and I would like to render them on the screen, which was pretty cool, right? So if I go to my map class, this is just a quick recap of what we've done. just real quick. So I'm loading the tile sheet. I'm printing that was successful. I'm figuring out how many total tiles I have on the x-axis and the y-axis, and then how many total tiles I have in general for both x and y-axis. So for example, maybe I have 100 tiles on x, or less than that. I have like 20 tiles on x and another 20 tiles or 21 tiles on y, and then you multiply those two and you get the total amount of tiles you have on the screen. I'm creating an array, right? So tiles is a pointer, and we talked about pointers before. Tiles is just a pointer which points to an array of specific amount of tiles, and I'm looping through that tile array. It's a one-dimensional array, so I'm looping through it. I'm assigning the IDs and the position. So I'm saying, hey, this tile. I'm saying, hey, this specific tile has an ID of, I don't know, 23, and has a position on this texture. The position of this tile on the texture is, I don't know, let's say 50 pixels by 100 pixels, for example, right? And so after I create that lookup table and I assemble all that information in my tiles, in here, I'm again looping through the tiles again. Why am I? Oh, I'm multiplying by 3 because that's the width of my. So okay, and so after I create my lookup table, I have this map. This is the map that actually I'm rendering on the screen. These are the tile IDs that I want to render on the screen. I have 120, 121, 122, 144, 145, and 146. Right? So I'm looping through that. I'm looping through this array. Right? So there are two rows. So this is row number 1. Let me put this side by side. Right. Oh, I switched back to Windows 10 because Windows 11 is garbage. Anyways, so I have 2 rows, right? You can see here 2. So this is row number 1. This row number 2, and every row I have 3 tiles. So 1, 2, 3. So I'm looping through those. I'm getting my I index. And again, I explained this formula: x plus y multiplied by 3. Y3 just because there's 1, 2, 3 tiles in one row. Getting my I. So using that I am accessing my map numbers. So I'm accessing this array, right? So I'm going through this array. I'm getting this 120 number and I'm storing it as an index. So this 120 is the index. Using this index, I am going to my lookup table, right? Going through my lookup table, and I'm saying at index 120, I want the position of that tile, right? And I'm doing that over and over and over. It's really that simple. So I go to 120, I store 120 in index, and then I go lookup table, I check 120, and then I go to 121. Index is 121. I go through my lookup table, and I assign my map sprite, right? So these are my map sprites. These are the sprites that I actually want to render on the screen. I have 6 of them. And the reason I have 6 is because I have 6 items in my map numbers, right? And I'm just assigning those sprites. I'm saying, hey, the sprite at 120 has the position, this position on x and y axis on the lookup table, and it has the width and height. Sorry, had to cough. Anyways, I set the scale and I'm setting their position. I'm setting the actual tile position in the real world, which is whatever x is in the loop, which would be, for example, 0, multiplying by 16, multiplying by 5. Why I'm multiplying by 16 is because I know it's each tile is 16 by 16, the width and height of each tile. If I'm not mistaken, let me double check that information. Yeah, each tile is 16 by 16. So I'm basically saying, hey, I would like the first tile to be at 0, index or position 0 on the map on the screen. And then 0 multiplied by 16 is 0, multiplied by 5 is 0, so this is 0. And then when index goes to 1, 1 by 16 is 16, and then multiplied by 5, so I offset it by 5. Why the 5 is because the scale is 5. I am scaling each tile by 5 by 5. So I'm essentially putting each tile next to each other. So I'm saying, hey, this is tile over here. It's at position 0. And then when x increments by 1, now I say 1 multiplied by 16. So I'm moving 16 pixels over. Multiplied by 5 because, well, the scale by 5. So whatever 16 is, multiplied by 5. So I'm basically moving the tile over that many pixels to the right. And then x goes to 2. And so I'm doing the same thing. I'm moving this many pixels to the right, and I'm rendering or placing that tile, right? And I'm doing the same thing for the y-axis. So I've done that. This is a really very quick recap of what we've done. And then here simply I'm just looping through my map sprites and I'm just rendering off them, right? We've done that. We've talked about this the previous lecture. If there are any confusions whatsoever, drop it in the comments and I will definitely explain this again. No problems at all, but that's kind of your quick recap. What I want to do, so I had an idea of creating a Discord for people who want to ask questions. I kind of want to build a community around this whole series. I haven't managed to do that. Maybe I'll do it on stream. I don't know. But I really want to finish this map editor kind of today, or at least in this lecture. All right. So this was just a quick recap, and I'm rendering the door, and that's all great. Okay. So the next step is rather than hard coding this map inside my C++ program, I would like to save it in a file and load it from that file, right? Because our editor is going to be completely different from our game. Those are going to be two different applications. So with our editor, if I go here, so this is my editor over here. So our artist or whoever is going to design the map is going to go place some tiles, lovely tiles, create the map, gorgeous map, save it to a file, right? This will be .map. The extensions don't matter. By the way, these extensions mean nothing. They're completely meaningless. The only operating system that ever uses these extensions is Windows. Only Windows cares about these extensions. Otherwise, in Mac OS or Linux, it doesn't really matter. Like, no one cares about these extensions, right? So if you put the extensions for your thing .map or .data or .bin, it doesn't matter, right? It just doesn't matter at all. So we're just gonna call .map, maybe, I don't know, we'll see. Anyway, so someone created the map, save it to a file, it's right here, and then here's your game, right? So your game will go load this map and display the actual map, which is gonna be cool. All right, cool. So let's do that. Let's save this data to a file rather than hard coding it. Now we have a few options on how we can do that. We can either create our custom file format, or we can rely on an existing file format like JSON or XML. Now, for those who don't know JSON, right, and seeing this is a beginner series, so I'm gonna have to explain everything as if you don't know what the hell I'm talking about. XML is a pretty popular file format. In fact, HTML, right, the language where you build a website, is made from XML, right? And it's pretty cool. So if I show you XML, this is what XML kind of looks like. And I used to be in love with XML. In fact, my previous engine was very heavily reliant on XML, which was pretty cool. But now I'm kind of falling in love with JSON. But anyways, XML is pretty cool. You just have tags, just like HTML. You have the bird tag, you have an opening tag and close tag, owl tag, opening tag and closing tag. And then there's some data. So for example, species, you can see there's some data in here, the name of the species, the region of the species, and so on and so forth. The owl has an ID. You can put attributes in the XML file, and so on and so forth. We're not gonna do XML, right? We're gonna create our own custom file format for a specific reason, because I want to teach you how to manipulate strings and how to work with strings. That's really, really important, especially if you go for job interviews. One of the questions will eventually be about strings and how to work with strings. So creating our own custom file format, while that might not be the greatest thing, because there are other existing file format that will make our job much, much easier, I want to teach you the hard stuff so you know and understand how to do it. We might later on switch to a format like XML and JSON and show you how to manipulate data with that. But for now, we're just creating everything from scratch. Anyway, so this is XML. This is how XML looks like, right? It's very similar to HTML. Open, close tag, and there's content in between. If I go to JSON, JSON or JSON is another file format that is, so XML can represent 3D models. Is Collada uses XML? There is a file format. There is a file format that uses text. Maybe it uses XML. I don't know. I don't remember. Let me check this out real quick. But I don't see why not. Yeah, you could use XML to represent a 3D file format, a 3D model. Why would you do that? It would be a pain. It would be a really big pain. To do that, you could technically, you could use any file format really to represent a 3D model. But yeah, I don't know. Why would you? Can I see Collada? How it looks like, please? Collada. Why am I on Bing? Bing, please, Microsoft. I'm begging you. Your search engine is garbage. We talked about this. Let me see how the Collada file format looks like. Any pictures of the file format at all? Collada format. It is XML. Cool. Yeah. So it is. I wasn't completely off. Yeah. So Collada is an XML file format, according to this at least. Can I see the actual file format, please? Please. I just open a bunch of these. Useless. All right. Yes. Here we go. Yeah. So Collada is XML based. Cool. So yeah, you could definitely use XML to represent 3D model. And there's a file format called Collada. It is created by the Coronas group. Digital Asset Exchange format. Yeah, it's created by the Coronas group, and you can use it for file formats. It's slow. It's not fast. It's not great. It is. You wouldn't want to use this in production or in an actual like production game. You wouldn't want to use any text format for production. The reason for that is you're taking a long time to kind of parse the file and kind of understand the content of the file. That takes a while. And we'll talk about what parsing the file means and all that. But usually you want to, whenever you ship the game, you want to use binary, right? You want to just take that file and dump it into the GPU or the graphics card right away. You don't want to spend time processing that file and your application trying to understand what it's doing, right? That's really slow, really bad. And that's why we have editors. So your game editor will go and deal with those kind of file formats, but when it exports the game, when it exports the 3D the final 3D model or whatever, you want to convert it from like an XML text file to an actual thing that your engine or game can understand and use very quickly, which would be binary. But anyways, I digress. We'll talk about this later. We need to save the data of each vertex or something. Yeah, so Collada will have data about every single vertex, about materials, bunch of other things. Explain XML stuff. Well, I'll definitely explain XML at some point. Not right now. Anyways, so XML is a popular file format, and it's used everywhere in a lot of places. And like I mentioned, HTML is XML based, and you can see HTML, you have an opening tag and a closing tag and so on. The other file format that's also popular, that's out there, is called JSON, and JSON stands for JavaScript Object Notation. JavaScript Object Notation is a file format that was built alongside JavaScript. JavaScript is a language that has plagued humankind. I actually kind of like JavaScript. I used to really hate JavaScript, but I kind of like JavaScript. It's a horrible programming language, but it's kind of cool at the same time. It's both bad and fantastic. And so JSON was created to kind of work with JavaScript really, really easily, which is great, which means you can just load JSON into JavaScript and JavaScript can just understand it and kind of figure out what the hell you're talking about. And it looks something like this. JSON would have a tag, again, with double quotes and a colon, and we call this as an object. Again, I'll just briefly explain JSON, just very briefly. I don't want to go into too much detail, but essentially, this is your root tag, and you have an opening brace and a closing curly brace. Let me just write JSON for you. Why am I doing this? All right, let's write a quick JSON file format, and I'll do the same thing with XML. So we start with double quotes, and let's say this is our data, or this is our map, right? And you want to create an object out of it. So this will be our object, our JSON object, or our initial Java JSON object, right? Inside, you can create another object, or you can create an array. Let's create another object inside. So inside a map, we want to know the width and height of the map, right? So what I could do is say width, if I can type, and I could say, hey, 16. So let's say tile width like this, and then a colon, and I could say tile height, and do another 16, right? So this is 16 by 16 each single tile. So we have information about every single tile. I could store more stuff. So now, for example, if I want to actually save the map, what I could do is say, I don't know, data. I'll have another kind of tag here. I could say data, and inside this, I'll have an array, right? An array looks like this, and I could put 120, comma. Let's see what I have here. I have 120, comma 121, comma 122, comma 144, comma 145, comma 146. So I'm just trying to replicate this, right? I'm just trying to copy this in. Right? And this would be our data, and this is our file format. It's all the data that I need to kind of load or create a map. I know the actual index of every single tile in my tile sheet. I know how big is every single tile, every single tile is. And if I want, I can put scale stuff. So I can put like, how we have, if I scroll down here, I have this scale by X, scale by Y. Man, what is up with... So we can do the same thing. For example, I could say scale X is 5. I could do scale Y is another 5, right? And this is JSON file format, right? Which is kind of cool. You don't have to name things like this. You don't have to put this dash or what do they call these? It's a thing, right? You can do it this way. You can put an underscore, however you want to name it, or however you want to do it, doesn't matter, as long as you have the double quotes, right? And so this would be treated as an integer, 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 and this is another integer, integer, integer. If you want, you can treat them as a string. That would work too. So just put double quotes on here, and that would be a string. If you want, you can have the name of the map, right? We could say name, and this is, I don't know, level 1, right? And another, don't forget that comma, right? And if I want to validate this and make sure this is actually a valid JavaScript object or JavaScript file, there is a Json Parser or formatter, just to make sure that it kind of it takes your file and makes sure that it's valid. So if I go here and check this out, oh, this is not valid. So the one thing I forgot is you cannot start with this, right? You cannot start with the name. You have to start with a you have to start with an opening closing brackets like these, right? So you have an opening, closing, and then you have your data in here. So it should be like this, right? So if I look here, JSON parse, you can see here I have one object. Inside that object, I have a map of what the fuck is the fuck? Dude, I don't want to buy Dying Light. The game is great. I know it's great. The reviews are fantastic. Go away. That's all right. Whatever. So I have refresh. Cool. Thank you. All right. So you can see I have one object. Inside it is the map. Inside my map, I have an object called name, which is level 1, tile width 16, tile height is 16, scale x55, and then I have my array of data. I have 6 elements in my array, as you can see, and inside that array I have 120, 121, right? So this is a valid JSON file format that you can use and load. I don't want to go into too much detail other than, hey, you start by having an object. If you don't know what an object is, I'll talk about this later whenever we learn JavaScript, and we are going to learn JavaScript in this series because we have to do server stuff, and part of it is JavaScript. So we'll talk about this later on. But essentially, you have an opening closing brace that would be for the JSON, and then you have an object and an inner object. There's an attribute, or I don't know what they call this, a value, not a value. Parameter, I don't freaking know what they call it, but you have a value, a variable, and a variable, and so on and so forth. Then you have your array over here. So we should have specific library to read JSON file, or we can read it manually fpx. Okay, so you can write your own JSON parser that reads this data, right? And we could write that. Like we could definitely write that. We're not going to though. It's too much work that is unnecessary and it's kind of boring. Instead, we're just going to create a much simpler file format that we could use for our own game. So you could write your own JSON parser that reads this file, or you could, I'm pretty sure C++ has um, in the std library a way to read JSON. No, I guess not. The C++ standard library, I could be wrong, but the C++ standard library does not read JSON. So you could just download an extension or plugin or library to put in your application to parse that JSON object for you. You could do that. But yeah, here's a library which you can use, which is kind of easy and yeah. So we could do that. Manually or fix our image format. So we should have specific library to read. Yeah, so like I said, you could either use a library or you could write it yourself. Cool. So there's that. So this is JSON, right? I'm gonna show you the equivalent of how XML would look like. So if I open a new thing and drag this out, no, all right, fantastic. XML would look something like this. So this would be the top level tag. This would be called map, for example, and you'd have a closing tag map like this. Inside you would have a tag called name, right? And you'd have called level 1 name like so. And then you'd have the same thing. So let me just copy this a bunch of times. You'd have tile width, tile width, tile width, tile height, scale x, and scale y. And this would be 5, 5, 16, and 16, right? For your array, your array is gonna look something like this, I believe. This would be data can just put your array like this as values, right? And you would read this as one big string, and then you have to split it off. There you go. That's how this would look like in XML. You could do it this way, right? These could be done this way, each one a node of their own. Or alternatively, you can put them as attributes of map. So it would look something like this. Name equal to level 1, right? And then space tile width equal to 16, right? And so on and so forth. So rather than put these as attributes, you can just put them all in the same tag, right? As part of that. I think that is a little bit cleaner, a little bit nicer. So let me just this off. I could put them on multiple lines just to make things a little bit more clear. Like so. So this would be scale X, scale Y. This would be tile height 5 and 5. Yeah. So there you go. This is all in one tag. I mean, you can imagine these are all in one line, but I just split it into multiple lines for ease of to read it. And this is just all part of a bunch of attributes for the map, rather than having them separate. And this is just another tag, right? So this is how XML would look like. Cool. There's no preference to using XML or JSON. The entire web development industry uses JSON because JSON is very close to Java. Well, it is with JavaScript, and the entire web development industry uses JavaScript to make websites, and so they prefer JSON. There are other people who prefer XML. Again, even XML is used in the web industry, but JSON is a lot more common. So whatever file format you use, it doesn't really matter. Both of them are text. Both of them are slow in terms of parsing. If you have a shit ton of data that you need to parse, for something like this, it doesn't make any difference. Like, this is not very much data, so it doesn't take a lot of time. For us, we are going to use our own custom file format. Our own custom file format would look something like this. So we're gonna make a tag, and I've designed it this way. You could design it completely differently. It wouldn't matter, right? However you design it, that's your call. So what I can do is I can just, I'm gonna put a tag here called map. And then in here, I'm gonna put some data about the map, like name. We can call this level 1, right? Just copy all this data over here. Name, I'll have tile width equal to 16. Right? And this is 5. Right? This is how our data is gonna look like, or how our file format map thingy gonna look like. I'm going to remove the spaces. It's just easier to parse without the spaces. It'll be something like this. And finally, our data. This is our map data. So we're gonna have a section here called data equal to this string over here, right? And so this will be our file format. This is how I'm gonna design it. This is how it's gonna look like. You can see it's not similar to XML or JSON at all. Very different. But yeah, this is what I'm gonna go with. Why do I have a map tag here? Just so I know that this is the beginning section of the map where I have to start reading some data about the map, like the name, tile width, height, and so on and so forth. And then whenever I see the data, I do stuff with data. For example, in my file, I could extend this file and I say I can have objects. So I can have another tag here, and I can say objects. Maybe there's an object, I don't know, a potion. And that potion has, I can say how would I do this? Potion. Potion equal. Oh, I could do this. 100 comma 20. So this is the position of the potion, for example, right? 100 pixels to the right, and 20 pixels down. So for example, this would be a potion. If I want to have more attributes, maybe I would make it this way. I don't know. Again, I'm just making this up as I go along. We're not gonna have this. We might have it. We might not. But the data we only need is this so far. But I'm just showing you how you could extend this later on if you needed to. So for example, this would be called position. Equal to, this would be called, for example, an icon. How would the icon be? And this would be like a path to your C drive. For example, you could say potion icon.png, right? And you can put a bunch of attributes however you want, right? But yeah, you can extend this file format however you want to. You can design it however you want to. Doesn't matter, but I'm going with this. I'm gonna leave this section, and this is our file format. All right, cool. So let's save this. This is my map, level 1, 16, 16, 5, 5, and the data. All right, I'm gonna save this. Where I'm gonna save it? I'm gonna save this on my desktop. Actually, I can't save it on my desktop because everything on my desktop is not shown, so I'll not be able to find it. Let me just save it here. I'm gonna create. Do I put it in world? Prison? Huh. No, I forgot one thing. Oh, this is crucial, very important, essential actually. I need to know which tile I'm loading, right? So tile sheet equal to the path of my tile sheet, and I'll just copy this path. It's not an absolute path. It's not great, but we'll do this and then we'll think of something else later on. Anyways, and this is called tilesheet.png. All right, so now in my map file, I know which tile sheet I need to load, the name of my map, the width and height of every single tile, the scale of every single tile, and the data that I want to render on the screen, which is awesome. All right, let's save this. Where would I save this? World? No, I'll just have a map folder section. So I'll call it maps, and I'll just call this level 1. Level 1. There you go. You could do it as txt. You could give it a different file format if you want to. It doesn't matter. You could give it no file format, which is also valid. It doesn't matter. We're gonna do what is this game called? 2D RPG, best 2D RPG in the world, something like that. I don't know. We could call it .map. Why not? It has an icon. It has a default application. Already someone using this extension. RMap? Sure, let's do RMap. R for RPG and map for map. Why not? This is our file format, guys. This is what we're using. Hell yeah. Alright, so I have my map. Let's actually go ahead and load this map. So let's do that. What I'm gonna create here. Alright, so I'm gonna create a new class. These are not organized. I don't like the fact that these are not organized. Maybe we should start organizing them. I'll make a new folder. Not in here. I'll make a new folder. This folder. How is this structured? Sorry, give me a second. Let me just see this. Oh, everything is just dumped over here. All right, that's great. What I'm gonna do, I'm just gonna organize this a little bit more than what we have it right now. So I'm gonna close everything. I'm gonna name this as CRC. CRC stands for source code, so all of our source code will be in this folder. I'm gonna move everything there. So we'll have our assets and SRC. Not CRC, sorry, SRC. So this is our SRC. We need to stick to a file like convention. My asset starts with capital A. This starts with a small a s, which is not great. So I'm gonna switch everything to small. I'm gonna go with this convention, so I'm switching everything up. So small f, small p, more s, small w. We'll stick with this convention. Present small p. SFX, SFX, textures, texture layers. Right. Sprite small, and there you go. All right, so we have everything kind of small letters, which is, well, except these. Let's switch these to reference and tile sheet. There you go. Everything is following the same kind of convention now. Everything's small letters, which is kind of cool. Hey, change your for function. Put constants instead of number. Change your for function. Put constants. Yeah. Okay, I understand what you mean. You're saying so in my for loop, instead of putting a 2 and a 3, I should put an actual constant. Yes, I am getting to that. So what I usually do is I show how to do the bad way, things the bad way, and then how to kind of improve them. And this is definitely the bad way. And the reason this is really bad, especially this 3, right? And these are called magic numbers. So the fact that there's a 2 over here and there's a 3 here, that can create bugs really easily. So imagine this, right? Imagine one day we decide that our loop or our array over here, there are not 3 items in a row. There's 4 items in a row. So let's do 123. Let's do 147, right? So now there's 4 of them. Well, first of all, I'm going to get an error because it's complaining. So let's fix that real quick to 8. And notice now we have a bug. We have a major bug. This is an 8 and this is a 6, right? These two numbers should definitely match. They shouldn't look like this. Not only does this not match, the fact that we have 4 items in one row and here it says 3, that's another bug. So never ever, whenever you're programming, you never ever want to just put random numbers. Even these. This 5 over here, this 5 is really, really bad. And the reason this 5 is bad is because my scale is 5 by 5. What if one day I decide my scale is going to be 6 by 6? Well, now the scale doesn't match, which is not great at all, right? So essentially what you would do, you kind of fix these things. So this would be like this, right? And you would do that. All right. So we'll go through this code. We'll clean all these problems, right? One by one. Give me a second. I'll be right back real quick. Sorry. All right, sorry about that, right? So you never want to put magic numbers in your code, and these are magic numbers. Numbers are just exist, right? This is another problem where we have 16 over here. This 16 is a magic number. It's the tile width, and this 16 is the tile height. So imagine one day I decide to change what the tile width and height is. It's gonna create a bug, right? So we'll go over all these and fix all these. No worries. So let me just control Z everything. But yeah, we'll go through all of these issues and kind of fix them in a second. You know what? Let's fix them now. Why wait? Let's just fix them now since we're already talking about that subject. All right, so how do we start? Let's start with these constants. So 6 and 6, those should match. So what I could do is I can make a const int what do I call this? Map size. I guess I could do map size over here. A non-static. That's not gonna fix it. How do you do C++? You can't just do an int. A non-static method reference relative to specific object. Oh, how do you do these? Right. What was the wiki? I forgot how to. Hold on. Let me Google it. Const C++. It was const expression or const ex. Bing, no one wants you. No one likes you. Please stop. Thank you. Don't support. Const expression. Will this work? No. I don't remember how to do this. Let's do 5. You're not gonna work, are you? Assign a value int map 6. Does not have to be constant. No. I don't think this works. Private int map. No, so you can't. So this is already private. Private has nothing to do with this. Man, I don't think you can do this in C++. I completely forgot. Hold on. Set array size in variable C++. Define constant. Yeah, that I don't think that would work either. Yeah, so see, he wants to do that. And this lovely fella is telling him, legal in GCC with extensions illegal in proper C++. Yeah, so you'd have to make a pointer of this. Not valid since the variable is a component type. Yeah, so here const expression and it's a function. Use constant. No, I mean I did do constant. So what's your issue? Okay, I mean yes, we can use a macro. So technically, you could use a macro. You could say, hey, define, and we haven't talked about macros before, which we could do. So I could say map array size, and I can specify this to 6, and I can use that. That is valid, right? So you can define. We talked about the preprocessor before, right? So the preprocessor, you could go anything that starts with a hash or a pound is a preprocessor directive. So you're invoking the preprocessor. In our case, for include is going to include the entire file over here. In here, we're actually defining a word that's equal to a value. So I'm saying, hey, define map array size with 6. So what's going to happen when the preprocessor runs, it's going to scan our entire code and look for this word. Whenever it sees map array size, it's going to take it and replace it with the number 6. And it's going to do that over here. Right? This works fine. This is perfectly fine. This is perfectly legal. We could definitely do that. But I want this to work. I'm trying to get to this to work. Okay. So define a pointer and set the size inside the cursor. We could do that. So we could do the same thing we're doing here with tiles. So with tiles, I could define a pointer like this, and you can specify the size of that array in here, and this totally works. But I want to see if I can make it work in here. I don't think the compiler, Microsoft compiler allows this. C++ GCC seems to allow it. Let me just search this real quick. And see if this is valid. We could use a vector, don't care. Initialize a variable size array. So he's doing a define, that's fine, but can we make a constant? Static constant. Oh, we did use static. But you wouldn't define this over here. You would do this. Leave it. Map array equal. I don't know if this is valid C++. Man, I haven't. I'm so rusty with C. Must have a constant value right here. Oh, there you go. Cool. Just make it static. Alright, cool. We haven't talked about static yet. We didn't talk about static at all. So just make it static constant and that should work fine. Okay. I believe we talked about constants before. I honestly don't remember, but I think we did. Let me just scan through the code here. Let me just try it. See if I can find a const word that we used before. Yeah, we definitely. So I explained const for references. Yeah, I definitely explained const. All right. So you all understand const. Just a quick refresher. When you mark something a variable as constant, you have to give it the value immediately, and you cannot change it later on. So I cannot say, hey, map size is now 7, right? Once you define it at 6, it is 6. We haven't talked about static though, have we? I'm searching through our project. We did talk about static. Okay, so we did talk about static. Apparently, I'll have to go back in the VOD and just make sure. But I created two static functions over here, and I wouldn't create two static functions without explaining them. So yes, I kind of did. But essentially, static. If again, a quick refresher. The static keyword just essentially means that hey, there's one variable, and one variable exists in this class called map size, and so every instance of the map class will have the same variable, and they're all gonna be equal to 6. I will go in depth about this later on. But there you go. Okay, private. You can't do this as you write in class header. Use a pointer as an array. Yeah, you do. Pointer and set. Yep, great work. There's no difference between a struct and a class. There's absolutely no difference between a struct and a class in C++. They're exactly the same. The only difference is that a class by default has a private scope, where a struct has a public scope by default. That's the only difference. They are literally the same thing otherwise. Not like in C#. In C#, a struct and a class are very different. Very, very different. And they use very differently. Anywho, so I made a variable, a const integer variable. I give it the value 6, and I made sure it's static, so C++ is not pissed off. I can remove this define now. We will use defines later on, so if you don't understand them or you don't know what they are, we'll use that later on, so don't worry. So this is my map size, right? And so what I can do now is go ahead here and be like, hey, right, so this is over here. So what I can do also is I need to define the x and y, for my loop. So this would be int map width, int map height. So this would be map height, and this would be map width. This would be map width over here. These, so since I defined the scale over here, reduce bugs, I can just replace this 5 with .get scale. So there's a get scale function in SFML, which I could use. X and Y. I'll split this into multiple lines just so it's easier to read. Like so. This 16, those two 16s are magic numbers again. We've already defined them as tile width and tile height, and they're defined over here 16 and 16. So rather than just typing 16 and 16, we're going to do that. So tile width and tile height. There we go. This 5 and 5 is fine. This 100 is fine. It's not an issue because I'm not using it anywhere else, so it's okay-ish. This 6 is definitely not fine. So this would be the map size. Right? What else do we do here? Clean up. And that's it. We're done. We're clean. We need to initialize the values. So map height, map width, tile, and total tiles. All of these variables are not initialized, and as I said in C++, it is beyond important to go ahead and define those variables. You have to give them a value. Otherwise, they're going to read whatever value in memory at that time. So this value could be 0, could be minus 100, could be a billion. And if you assume it's 0 and you add 1 to it, you're not going to get the answer you're expecting. So you always want to try to, well, not try. You always want to give default values to these. So total tile will be 0. Tile width, we have tile width, tile height, of that, we have these two. Okay, what else do we? Map width and height, so let's copy these. Map width and map height. These values would be 0 and 0. Actually, would they be? No, they would not be 0 and 0. Map width would be value 3, right? Because there are 3 of them. Yeah. So map width 1, 2, 3, and height would be 2. So these are not 0, 0. Total tiles. Do I compute that? Yeah, I compute it later on in my code. So that should be fine. What else are you complaining about? Tiles, map tiles uninitialized, or tiles. Oh, okay. So this is the pointer. You always want to initialize your pointer to null PTR, which is null pointer. You're a great teacher. Oh, thank you so much. I'm glad you're enjoying the lecture. Really appreciate it. But yeah, if everything is fine, I should compile this and run it without any problems. And it should work just fine. Hopefully. And there you go. It works exactly the same way. We just now prevented a buttload of bugs that could creep out at any second. Alright, so fix those bugs. That's all done. You could put this all on one line, by the way. Again, I split it into multiple lines just so for readability. Okay, so we organized our stuff over here. We cleaned up the code, which is great. We have everything in the source folder. I'm gonna create a new class. What do I call this class? So this class is responsible for reading the map, right? Reading to a map. Well, just reading the map, really. So map reader, no. Map parser, no. Map loader, no. Map. We can have a function in our map called load. But that would be so much stuff in one class. And that's iffy. No. Map loader, map leader, map loader, map reader. I guess map loader is fine. If I find a better name, I'll refactor the code and kind of clean it up later on. But this seems fine. We haven't talked about Pragma once. I realized that we haven't talked about Pragma once at all. Alright. Let me just put these two files, these lovely files, in my source file. Just drag them in the CRC like this. Right. Pragma once, what this is, it's your header guard. There's a concept in C++ called the header guard. Essentially, Pragma once will make sure you're only including one header, one of the same header. So let me give you an example. If you go ahead and do include, I don't know, map.h, and then you're doing include map.h again. Just say you're doing it twice, right? What Pragma does is make sure you're only including it once. Unrecognized, include, so include, right? So that's what Pragma once does. Now you might look at this and say, I'm not stupid. I'll never ever include map twice or two headers twice. I mean, it's obvious you're doing it twice, but you see, sometimes it's not obvious. Sometimes you could do this. So let me find another script. All right, let's assume bullet. Bullet, for now, let's just assume bullet includes the map class for whatever reason, right? And so what you've done here essentially is you've included map and then you've included bullet, right? So how many times did you include map? Twice. The first time over here, and the second time you included bullets, which includes map, right? Which means you included map twice. And Pragma once essentially makes sure that you only include this once, or you only include a header file once. So that's kind of, let me just Control Z this because we don't need this anymore. But there you go. So that's what Pragma once does. It makes sure you're only including only one header file of a certain header. All right, map loader. What does this need? This has to be public. This lovely class, has a function called load, which takes a string. Actually, just a string, std string of file name. We need to include the iStream header. Anything other than load? I think that's it. That's all we need to do. Map loader, load. This will not return a void. I don't think it will return a void. It needs to return the data it loaded. So what I could do here. So okay, here's the thing. You know what? We'll deal with this later. Just take it baby steps. Let me just make the function, implement the function, and kind of take it one step at a time, without just one step at a time. All right. So let's read the file. Right? How do you read the file in C++? Well, it's easy. If I go to the documentation, if you go here, read / write file C++, right? Input output C++. First link. This is the official kind of C++ website documentation kind of thing. And if you look here, this is the easiest one, right? Writing to a file is the easiest thing. So you have include iostream, include fstream. Those are your two headers. We know iostream. We've used iostream before. Fstream is F stands for file stream, which has both open input and output. So you could, using this header, you could use it to either write to a file or read from a file, right? So we include fstream, and then we create there's a class called offstream. The O stands for output, the F stands for file, and you have your stream. If you don't know what a stream is, stream programming. So stream, you can think of a stream as a pipe of data, right? You're funneling data through this pipe. And And you can have a bunch of different streams. You can have a stream for a network stream, You can have a file stream, and a bunch of other things. So, for example, stream, meaning C++ or C programming. In computer science, a stream is a sequence of data elements made available over time, right? The way I explain it is you can think of it as a pipe, and just data are going through that pipe. So that's here. Yeah, there you go. Here's a pipe, and there's data just going through that pipe, and being collected, right? Or you can think of it as a river. Data are being funneled from the source to the destination, right? You can think of it many different ways. Essentially, that's what a stream is. So in here we have an output stream, output file stream. This is a class. I'm creating an object out of it called my file, and I'm saying, hey, open my file. I'm saying my file dot open. Open is a function which takes the name of the file you want to open. Once you open it, you're writing data into my file. Once you're done, you close the file. And so now you've essentially written this string into the file, writing this to a file. So I'll show you an example. We don't need to write data right now, but I'll show it to you anyways. I remember these days when I was everything. I have to do everything from scratch now, but I lost my mind with optimization and SIMD stuff. You know about that. So yeah, SIMD stuff it's fascinating. It's pretty cool. But if you're doing that, I think back in the day when you had to do SIMD optimization, you had to write assembly. But then C and C++ kind of supported it with a higher level language like C++. But yeah, no, I know what you mean. It's kind of a pain to do things like SIMD optimizations and deal with SIMD registers. But yeah, all right. So let's write to a file. We don't need to write to a file right now. All we need to do is read to it. But let's just write to it. The easiest way to do this is just put it in the main function. Oh no. Yeah, there's a buttload of stuff here. Never mind. I'll just do it here. I'll make another function called save. Even though we do not need the save function, I'm gonna do it either way, just to kind of demonstrate how you can save to a file. We will save to a file with our editor later on, but let's do it anyways. All right. So if I look at the documentation here, what do we need? First, we need to include the Fstream header. Let's do that. Let's do include Fstream. So again, whenever you're including a header file, you always want to ask yourself, should I include this header file? Is it fstream.h? There's no .h. Why is it? Why are you complaining? What's wrong? Oh, the R. I forgot the R. All right. So whenever you're including a header file, you always want to ask yourself, should I include the header file in my .h file, or should I include it in my .cpp file? And we talked about this before, and we said, hey, if you are going to use the Fstream header, or if you're going to use this header in the header file, so if I need some functionality here, like for example, what do I need here? I need ofstream. So if I'm going to do this, if I'm going to say ofstream, I'm going to call it file stream. If I'm going to do this is std. If I'm going to create this object of type ofstream inside my header file, sorry, I had to cough. If you are going to create this object inside your header file, then yes, you need to include your header over here. But we're not doing that. We don't create this object over here. So this technically doesn't need to exist here. So let's just include it in the C++ file, right? And the reason we do this is a little bit for optimization. Because if we include this header somewhere else, we're gonna include Fstream in multiple places, and our compilation time will increase. It'll take much longer to compile your application. But if you include them in the CPP file, this only gets compiled once. So it's kind of a nice optimization you do, right? So I don't need Fstream to be here in the header file. I'll just include it in CPP. All right, what do I need? I need std Fstream. I'm just gonna call it file. So I'm gonna say file.open. I'm just gonna call it best map worldwide dot map or rmap. Right? So I'm opening my file. Now I need to funnel data, or I need to put data or save data inside this file. So I do file. This is my map. Right? And then I'm gonna do std and l. And I'm gonna do file. Again, one more time. I'm gonna do 124, 125, 126, 144, 145, 146. Right? And another std and l. And file.close to close my file, and we're done. That's all we had to do. This is really it. It's as simple as that. Saving to a file is really easy. So let's actually execute this function. Let's make it work. And this can be easily done. So if I go to my, I forgot the source code. We go to my main.cpp. Yeah. All right. If I go include, what do you call it, map loader. Oh, I misspelled this. I called it MPA loader. All right. Well, let's fix that. It's supposed to be called map loader. Yes, it's 11 p.m. Bear with me. Apologies for the mistakes. All right, let's fix all these spelling mistakes. Map loader. All right, and let's map loader. All right, so I'm including my map loader in here. I'm gonna create an object out of it called map loader, and I'm just gonna say map loader dot save. All right, so in theory, what should happen? This is what I expect. If I go to when I run my program, I should see a file being created, I believe here, if I'm not mistaken. I don't remember. Let's see. I don't know where it's gonna be created. I forget. Let's see. No, we have an error. Takes 0 arguments. Yeah, sorry about that. So this would be called map.txt. I mean, it doesn't matter. In fact, we're not using the file name. So let's use the file name here over here. So this will be file name and just pass it in. This. All right. So if I run this real quick, do I expect the file to pop up over here? No. Do I? Oh, it is. There you go. I wasn't completely wrong. There. Best map in the world. If I open this in Notepad++, this is my map 124. Right. This is exactly what we've written over here. Right. So we saved the file. There you go. This is as easy as it is. Again, to go through this one more time, I have a function called save. This function takes a parameter or an argument called file name of type string. This function is not going to return anything. It's void. It doesn't return anything. My function is called save. All right. This function has inside it, I created an object called file. This object has a data type of offstream. Offstream, the O stands for output, F stands for file, and stream stands for, your data stream. You can think of it as a pipe. Once I create my object, I open the file. This is the file name. You can specify the file name or the file directory. So for example, if I want to save it in my C drive, I can do this. So C : slash this, right? And so now if I go to my C drive, right, and I run my application, you should see my file pop up here, right? Because that's where it's going to be saved. Are you going to pop up here? Refresh. Excuse Excuse me. What? What? Okay, hold on. What? Open. This happens all the time, by the way. It's fine. You get used to it. Fstream string. Okay. This is the file name. Let's specify the file name and the entire directory of the file, which is C drive. Can I not save stuff in my C drive? Okay, let's try D drive. I think I'm not allowed to save stuff in my C drive. Let's see my D drive. If I press play, it should show up in here. There you go. Right? It showed up in my D drive. For whatever reason, you're not allowed to save stuff in your C drive. It's stupid. It's dumb. I don't get why. But there you go. So for example, if I wanted to save it inside my Steam library, right? So I can specify the path. I could say D drive, Steam library, colon that. So now if I open my Steam library, the file should pop up over here. So if I press play, it pops up over here. There you go. This is my file. This is my map file, right? So I can specify not only the file name, but the directory where you want it to be saved. If you do not specify the directory, it will be saved inside your project, right? So that's that. So I say, hey, I take my object, which is a file, I open it at this specific location or this specific name, and I'm just saving data, right? I'm taking the string and I'm pushing it to the left inside this object. And then I'm taking this end line, pushing it to the left, right? And then same thing with the second line. And then when I'm done writing to my file, I just close my file. That's it. That's as easy as humanly possible. You can make this, which is cool. So we're not going to do save. We're going to do load, right? Save is easy. We're doing save later on, right? We're doing save in our editor, but we're going to do load right now. Okay, so we're going to modify this. Instead of save, this is going to be load. And what do I want to load? What do I want to load? I would like to load this file that I created, which exists in assets. This has called m map small m maps and level 1. All right, so I would like to read this file or load this file. So how do we do that? Well, it's pretty easy. In here, we're going to do assets slash maps slash level 1 dot r map, right? So this is the path, right? Why didn't I specify the entire path? Because, you know, your project knows where you are. It knows you're in it knows you're over here. So it's gonna go to assets and then maps and then load this file. All right, so I specified the path for load. Now we need to actually open it and load it. So how do you do that? Well, going back to the documentation, the C++ documentation, let's see how that's done. So we're done with saving. Let's look at loading. All right, so Fstream, this is again Fstream, Fstream. This is the one where we load. Fstream, the I stands for input. So I am reading a file stream. All right, what do I need? Same thing, Fstream. So let's include that. We have Fstream. We're done. Next, I need a line. So whenever I read a text file, I read it line by line. So if I go to Notepad++, I can find it, right? Yes, keep this please. When I'm gonna read this file, I'm gonna read the first line, do whatever I want with it. Then I'm gonna read the second line, do whatever I want with it, and then read the third line, and so on and so forth, right? And so that's why I have this string line. This is where I'm gonna save my data. I create an object called my file. The data type of this object is ifstream. The I stands for input, the F stands for file, the stream stands for stream. and I'm specifying the location or the name of my file. Once I create my object, I'm checking if my file is open. If it's being used, or I think is open checks if it's being used currently or not by the operating system. Checks if the file stream was successful opening a file. You could do it by calling member is open, right? Okay, so it checks if you've successfully were able to open the file, because, and this is a function, if you are not able to open the file, you're gonna you can see here the if statement. The else statement says unable to open file. So there are a bunch of reasons why you are not able to open the file. One, the file doesn't exist. Two, the file is being used by the operating system for whatever reason, so you don't have access to it. Three, the directory is wrong. Four, your SSD is dying or your hard drive is dying. Five, the sun is crashing into Earth and computers are confused. Yeah, that's possible. I don't think anytime soon, but sure, why not? So those are some of the reasons why this would fail, right? The first two are most likely. The rest is a bunch of bullshit. Okay, cool. So let's do Fstream. You can see there's a bunch of options here, which is kind of cool. So you can specify what type of file you're trying to read. Is it binary? Is it text? We're not gonna specify any of these options because it's gonna be simple, as simple as possible. We're just gonna say Fstream, open the file, and by default, it's gonna figure out that it's we're reading binary file. Where's the text file? By default, it's gonna figure out that it's a text file, or by default, it always reads a text file. Here, this is the simple version of this, right? All right, so let's do this. Let's make it the line. So string, so std string line. So this is where we're gonna store our line. Next, we need an if stream called file, right? And this would be file name, which I specify over here. Man, I keep forgetting the R in Fstream. What is up with me? And this is also std. What's next? Documentation. I need to check if it's open. So if file dot is open, if I was successfully able to open the file, then great. If not, I have an else statement that basically says std cout unable to open file name and stdl for whatever reason. All right, unable to open it. Cool. What's next? Once we open this, we have a while loop. This while loop, we talked about while loops, right? So in our while loop, we have a function called getLine. The getLine function essentially is going to read line by line. It's going to read line by line from a stream and save it into a variable, right? So if I do while getLine, I think std getLine. Okay. What am I missing here? Line. Is it not an std? Why are you being like this? GetLine is in string. String. I thought string is included with iStream. I'm including iStream. GetLine is undefined. GetLine. There you go, getLine. And you have to include the string header. But there you go, getLine. All right, so getLine. You need to specify the stream you're trying to read from, and then where you're gonna save each single line you read. Right? So getLine takes the first argument, the stream, the second argument where you're gonna save every single line, and it's a while loop. It's gonna go through every single line in your text file and read it. All right, next, I'm just gonna print the lines, every single line. So std cout line and std and l. And when I'm done, when I'm finally done with my file, it is extremely important to go ahead and close it. Close your file, because if you don't close your file, that's gonna be an issue, because maybe some other application is trying to access your file and they can't access it because you never closed it. Maybe the operating system is trying to access it, but it can't because you never closed it. You could corrupt your file for whatever reason. Just always make sure you close your files, right? You open it, you read it, you're done, close it. All right. Let's am I calling load? I am calling load. Let's see if this works. In theory, I should see the content of my file. Why is there a breakpoint here? In my terminal command line, and there it is. Look, map. Let's open my file. Where is it? All right, cool. Can you open? Thank you. All right, look. Oh, I hate you. This. See, sometimes I shake the window like slightly or do a stupid movement, and Windows think that I want to minimize everything, which I really don't. So Windows, stop doing that. It's kind of annoying. Thank you very much. Where's my stuff now? Thank you. Again. Cool. All right, so you can see here, loading map, loading this line, loading this line, this line, this line, this line, this line, and data. All right, so I'm loading my file successfully. Hooray, guys, we did it. Woo! I've loaded my, whatchamacallit. I've loaded my file successfully, which is kind of cool. All right, so now we need to actually parse the file. What does parsing the file means? Parsing the file essentially means reading every single line and making sense of it. What does it mean to read map? What does it mean to read file sheet? What does it mean to read name or tile or so on and so forth, right? What does all these things mean? How long have I been streaming? I just realized I haven't been recording at all. So there's only a stream and no recording, which means I have to download this entire stream again after YouTube is done. Good job, me. Good job, me, for forgetting to record this. How long have I been streaming? An hour and a half. All right, let's I want to call it off. I want to keep those lectures an hour and a half maximum, but we're getting to the exciting stuff. Let's just do some small parsing and then we can continue later on, or I can stop the stream and start a new stream, another an hour and a half session. I don't know. We'll see. But anyways, what I could do here is I could do this. If line equal to map right stdc out, we are reading the map section. That's the end of, right? Which is kind of cool. And else, I'm just gonna print the rest of the file, right? So we have an if statement now. Now we're parsing. This is parsing. I'm checking if the line is equal to this. If it is, I'm gonna do something, right? Let's actually see if this works. And there you go. So you can see here it says, hey, we are reading the map section. We didn't print the map, like this top section. We didn't print this. Instead, we said, hey, we are reading the map section, which is kind of cool. All right, so if I'm reading the map section, which means I am in the correct file, how about we parse this? Let's parse this line of code. So tile sheet, right? So the next thing I wanna check and read. So if I'm reading this, then great. What I should do is continue. Continue. So you might not know what the continue keyword means. The continue keyword basically means, hey, okay, go to the next loop iteration. So, just literally go to the next loop iteration. How can I explain this any better? Read the next line. There you go. That's how I can explain it better. Continue means go go to the next loop iteration, and the next loop iteration is reading the next line. So it's like saying, hey, go to the next line, essentially. All right, so if this is the map, I want to have a boolean here, bool map exists equal to false. And so if map exists equal to true, and then I continue. And so now when I go ahead and read the next line, I'm gonna have a section if map exists, then hooray to us. This is the correct file format, right? And so, by the way, when I do continue, this code will not be executed because it's gonna kind of skip everything under it and just go to the next loop iteration. Go to the next loop iteration. All right, so map, if map exists, this is a boolean. If it's false, it becomes true here. If the map exists, what do I want to do? I would like to print this line. Right, I'm no longer gonna print these lines, all the lines. I'm just gonna print specific lines. So in theory, this code, what it's gonna do is go through the file, read it line by line. The first line it's gonna read is the map. If it reads the map, then the map exists, and we should continue to the next loop iteration, which is great. However, if it doesn't, I should break. Break meaning I exit the loop. Before I break, I'm gonna say stdc out. Map file is not valid. Or let's go. Our map is not valid. Or we could say it's corrupted or something like that. Because we know that our custom file format always starts with this tag. If it doesn't start with this tag, then there's something wrong with the file. Right? So let's test this. We read line by line. If the tag is correct, then we say that the map exists and the map is correct, and then we continue. Continue meaning we skip over all of this and we go to the next line. Reading the next line, we say, hey, is this line the map? If it doesn't, it's gonna exit and say there's an issue. So that's not good. I found a bug in my code. So what I can do here is I can do the following. I could say the following. If the map doesn't exist, or this is a horrible variable name, map is map valid, or just map valid, or is it map valid? If the map is not valid, which is at the very beginning when I start my application, the map is technically not valid, right? So if the map is not valid, I should check the line if it's map. If it is map, then I should say, hey, the map is valid, and I can continue the next line. So, and then I never execute this anymore because map is valid. So the next loop iteration, the map is valid. Let me go through this again one more time. I have a variable called isMap valid. It's false. I am looping through the file and I'm reading the first line. The first line I read is this. Now I'm checking. Is map valid equal to false? So whenever I do whenever I do exclamation mark is map valid, it's the same thing as if I'm doing this. I'm saying, hey, is or if is map valid equal to false? Is this false? This variable, is it false? Which it is at the very beginning. So it is false. And so I check the line. Did the line that I read equal to this? Yes, it is. So I say, is map valid equal to true? I make it true. And then I can continue. When I continue, I skip all the code under it and I go to the next loop iteration. The next loop iteration reads this line of code. Now it says, hey, is the map valid? Yes, the map is valid. We made it valid in the previous loop iteration. So I don't need to execute this code anymore. And then I can execute the rest of my code, right? So that's how this goes. At least I think that's how that goes. Let's make sure. So if the map is valid, I should just print that line of code, right? Let's test this. And there you go. That's correct. So if the map wasn't valid, I would have gotten this print statement, which says our map file is not valid, which is not great. But if the map is valid, we're printing every single line. So I'm printing line and then next line, next line, next line. Now, let's mess with the file. Let's say map X. So in theory, this should say map is not valid and it should give me an error. You see, our map file is not valid. Cool. So now this is just a cool way to verify whether the map or the file has been corrupted, or does someone tampered with the file, or, for whatever reason the file is not correct, right? Anyways, so I'm reading this, so the map is valid. Let's now read this. I did read this line. How about we parse this line? Right, how do we parse this line? That is the question. Well, here's the thing. If you notice, if you look at all my variables, I have the variable name and then an equal sign and the value. Variable name, equal sign, and a value. Variable name, equal sign, and a value. And so on and so forth. So every variable has an equal sign and a value next to it. So what I can do is I can say this. The first word is the variable, and I will split the string. I will literally cut the string in half using the equal, because I know every one of these has an equal. So I'll take the equal. This would be the actual variable name, and this will be the value of my variable, right? Let's do this. How do we figure this out? Well, it's pretty simple. What I could do is I can do this. Line dot was it split? Subster. Yeah, subster. So I want to subster. Subster is a function, which we'll talk about in a second. So 0. The maximum count that I would like to subster is, we'll figure that in a second. So I need to do line.find. Find with the character of equal. Again, I'll explain all these in a second. No offset, so this should be fine. So this would be int index, and then index. Subster takes count. Should not index, it should be count. Count. And so subster will return the variable equal to std string. And then let's print the variable. Right? Once I do that, I'm just gonna break to exit out of the loop. Right? Let's test this code. Let me just make sure this code actually works before I explain it. It does. It prints style sheet. This is brilliant. This is fantastic. And so the next thing I want to do is the value. And the value starts from count until line.length. Is it dot length? No. Can we do this? No. Size off? No. I think it's length. That's fine. Minus count. So I can do the value over here. Let's see if this works. Yeah, so it did work. You can see it printed the equal sign. But so I'm gonna do here +1. And that should work. There you go. Okay, cool. All right, so this code works. Not at all idiot, so that's great. So let me explain this, and then we're done. After I explain this, I'll turn off the stream and they'll continue this later on. Or you can do this as an exercise, kind of continue yourself. But let me explain this. C++ has some string manipulation functions which are awesome. One of those functions are called subster. Subster is a really cool function that essentially cuts the string between two sections. To give you an example, let's say I have the string std string name equal to my name is David. What I can do is I can subster the string, or I can split the string, or cut the string, or trim the string, whatever you want to call it. How do I do that? Well, what I can do is do name dot subster, and if you look at the function, the first argument is the offset, right? How much offset, how many characters you want to offset, or where do you want to start cutting? And essentially, it's saying where do you want to start cutting. And so we know, if I look at the string, we know the indices of the string, right? This is index 0, index 1, index 2, index 3, 4, 5, 6, 7, 8, 9. Oh, this is going to be annoying. 10. Double digits is annoying. How do I do this? I'm just going to use letters. A, B, C, D, E, F. Right? So 0, index 0 is the M, index 1 is the Y, the space is index 2, the 3 is index, the N is index 3, the A is index 4, the M index 5, the E is index 6. The space is index 7, I is index 8, S is index 9, the space is index 10. I'm using A as 10 because I can't fit the number 10 here. It would take 2 spaces, right? So I'm just representing 10 with A. D for David is index 11. A is index 12. V 13. I is 14. And D is 15, right? So this ABCD is just representing 11, 10, 11, 12, 13, 14, 15. Just because I can't put 10, 2 to kind of explain this well. Anyways, so there you go. So now I want to start cutting, right? Subster says, hey, where do you want to start cutting? At which index? Let's say I want David, right? I want David to start cutting from David. So I know I can start cutting from index B. What is B? Well, 9, 10, 11. So 11. I want to start from index 11. And again, we always start from 0, remember. Now, the second question, or the second argument, how many letters do you want to cut? Well, David is 1, 2, 3, 4, 5. I want to cut 5 letters. Right? And so I can save this. A subster is going to return a new string for me. So std string name, or David's name equal to, and then I can print this std cout David's name. Right? Now, in theory, this should print David. And there you go, it does print David. Look at me. I'm a good programmer. Who would have thought? Oh, it was horrible. So, again, the first argument is where should I start cutting? And I'm saying index 11 because 9, 10, 11. The A is represents as 10, the B is represents as 11, right? How many letters do you want to cut? Well, I want to cut 5 because David has 5 letters. 1, 2, 3, 4, 5. If David had 6 letters, let's say David's with an S, then I cut with 6 letters. So if I restart this, look now, it says David. If I restart my program, it should say David's with an S. Right? You can see it's David's, right? Which is kind of cool. All right, so now the question is, what if I want to cut the name? What if I want name? Well, easy. 0, 1, 2, 3. I want to start cutting from index 3. How many? So 0, 1, 2, 3, right? How many letters is name? 1, 2, 3, 4. There's 4. So in theory, this should print name on the screen. And it does. See, name, right? And that's what subster does, which is cool. So what am I going to use subster for? Well, essentially what I want to use subster for is I want to say I want to cut the variable tile sheet. So I want to cut from 0 until this equal mark or equal sign, right? I want to start cutting from the start until I reach the equal sign. So this will be my variable. And then I want to start cutting from the equal sign till the end of the line, and that would be equal to my value, right? So I want to do that. All right, let's do that. So how do we do that? So we have a question right now. We know how to substring, right? I know how to cut. The question is, I know where I want to start. I want to start from index 0 because that's the beginning of my line. The question is, how do I find out the index of the equal sign? Well, there's another function for that. The find function. The find function inside line, the find function finds a specific character inside your string, right? The character that I'm trying to find is the equal sign. So it's going to go through this. The computer is going to do this. T, are you equal? No. I, are you equal? No. L, are you equal? No. E, are you equal? No. S, are you equal? No. H, are you equal? No. E, are you equal? No. E, are you equal? No. T, are you equal? No. Equal, are you equal? Yes, I am equal. Equal is equal. Oh, that's cool. Oh, fantastic. And it just returns the index of that. I don't know why that was so dramatic. I'm sorry. But the equal is equal, right? So once it finds where equal is, it returns the number or the index of where that equal is in the string, right? And in my case, this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be index 9. If I go and print out this, it should print 9. I took out my wisdom teeth 2 days ago, my upper and bottom wisdom teeth 2 days ago, and my jaw. And I took ibuprofen to help with the pain. And I think ibuprofen right now is wearing out. My jaw is killing me right now, but it's fine. And you can see it's printed 9, right? So like we expected. So the question is, you might have this question, and you might be like, hey, dude, this all is cool and great, but what if you have two equal signs? What if, for whatever reason, you have an equal sign over here and another equal sign here? Which index is it going to return? Is it going to turn this equal sign? Or is it going to turn this equal sign? Well, find will always return the first equal sign it encounters. So the first equal sign it encounters, it's going to return the index of it. In this case, it's going to be 0, 1, 2, 3, 4. It's going to return index 4. So the question is, how can we get the second equal sign? Well, you can do another argument of find is an offset, right? So if I can do an offset of 4. So an offset of 4 because 0, 1, 2, 3, 4. I'm offsetting by 4. I'm moving by 4. Yeah, right? An offset 4, meaning it's going to ignore this equal and it's going to try to find any equal sign after index 4, which is kind of cool. And so let's see if that's in practice. If I save this, count should return 4, right? Because this is index 4. There's an equal sign at index 4, right? So this returns 4, which is correct, right? Because 0, 1, 2, 3, 4. All right, if I do an offset of 4, so I'm ignoring the first 4 characters, I should get an index of 4 again because I'm an idiot. It should be an offset of 5, not 4. And I'll explain why that in a second. But if I do an offset of 5, now the next index is 10. And let's see, is 10 correct? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the next equal sign is 10. So now the question is, why did the 4 not work and the 5 worked? Well, it goes like this. 0, 1, 2, 3, 4. If I say an offset of 4, I am at 4. And if I am at 4 and I look at 4, hey, 4 is equal. There's an equal sign at index 4, right? So that's why I do 5, because it'll be like this. 0, 1, 2, 3, 4, 5. I am at 5. S is not 5, so I'm going to continue searching from S. Where before, if I had this at 4, I would start searching from the equal sign, which is, I am at the equal sign, which means I just return back the equal sign, right? Which is index 4. Cool. So that's how the find function works, which is cool. So now I know how to find the index number of this equal sign, right? And so I can now subster. I can subster from index 0, from the beginning of the line, until where my equal sign is, which is over here. So I go ahead and do that, right? I cut the string, and it's now printed or saved in variable, right? So if I go ahead and print this, you will see that when I print variable, it should only print tile sheet. I didn't save my file. Hold on. There you go. It should only print tile sheet. For whatever reason, let's say this variable is longer. The name of this variable is longer. Tile sheet. Ooh. 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 La la. Right? It doesn't matter how long this variable name is, because I'm only getting it. I'm only getting it at the equal sign. Don't worry, I'm a dentist here. Oh, really? Oh, that's pretty cool. And there you go. You could say tile sheet, ooh la la, right? Which is kind of cool. All right, so we've done that. We figured out the variable, right? Let me just delete all this. I figured out the variable. Let's figure out the value now. So the next part. So we figured out this part. Now let's figure out the next part. So to figure out the next part, we know. So we want to start cutting the next section. So now we know that we should start cutting from count. What is count? Well, count is the index of the equal sign, which we found at the very beginning, right? So index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I know that I should start cutting from index 9 until the end of the line, right? I want to cut all this out. And I want to save it in the variable called value. So I start, subster is starting to cut from count, comma, how many letters am I supposed to cut? Well, I'm supposed to cut the entire length of the line. But the entire length of the line is this. This entire thing that I just highlighted. And if I do that, the application is going to crash, because if I start cutting from here and I cut at the very end of the line, there's not many characters. Like, how do I explain this? There are a bunch of characters that are missing, right? So let's say this entire thing is 15 characters, but the entire length of the line is 20 characters. So if I start cutting from here, I need to count 20 characters from the step, but there aren't 20 characters, it's only 15, right? So I need to do some math. I need to say, hey, cut the offset, cut until the end of the line, so from here until here, right? Minus the count, and the count is this many characters. All right. So essentially, I am saying this: if the entire line is 20 characters, and the first stuff we cut, the variable we cut, is 5 characters, so now the rest would be 15 characters. So when I should start cutting is from index 5, and I should cut 15 characters, right? I shouldn't start at index 5 and cut 20 characters, because this entire thing is 20. I just want to cut this section, which is 15 characters. I'm assuming these numbers, right? They're not actual real numbers. We're just assuming them for simplicity's sake, because I don't want to go ahead and count every single character, right? So this is 15 characters over here. I'm cutting from this index until all 15 characters. That's the math behind it. So again, to cut the value, I'm telling subster where to start cutting. I want to start cutting from count. Why count? Because count is where the equal sign is. So I'll start cutting from the equal sign. Now the question is, how many characters am I supposed to cut? Well, if I get the entire length of the line, which is all of this, minus count, which is how many letters and came before the equal sign, right? If I do that math, let's say I get 15 characters. So I'm going to start cutting from here until the very end of the line. Where if I don't do this math and I just do line.length, which means I'm going to start cutting from the equal sign until the end of the line. But there are even there are more characters. I'm saying there are more characters here, but there aren't more characters. Right? So I'm saying I'm going to start cutting from equal till the end of the line. But the end of the line, this entire thing is the end of the line. I'm explaining this really horribly. I hope this makes sense. If it doesn't, let me know. I'll just explain it again. But yeah, just do the math in your head for a second, right? And it'll make sense, right? I'm just doing an offset. All right, cool. I'm really not happy with this explanation. I don't think I can leave it at that. Let me try again. And I'm sorry if you can skip over. I put chapters in the video, so you can skip this over later on. Let me just do this one more time. And let's actually write it in. Let's actually do the math here, because I'm not doing it justice. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So until the equal, there are 9 characters over here. Alright, let's count this. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66. So at the very end here, this is 66 over here. And this is 0. Right? Okay, this will make a lot more sense now. First, we cut the variable from index 0 until count 9. So we cut this section. We start from 0, we count 9 characters. Next, the value. We're going to start cutting from 9, right? The count is 9. So we're going to start cutting from 9. If I just say the line length is 66 characters. But guys, if I start from here, there aren't 66 characters. If I start from here, there are if I start here, this would be if you do just simple math, 9 minus 66, or sorry, 66 minus 9. This is 57. There are 57 characters. If I start cutting from here, there are 57 characters only. So if I do line.length, this will return 66 because this entire line is 66. And if I do this, if I say, hey, start cutting from 9, and until you reach 66 characters, the application will crash because there isn't 66 characters. There's only 57 characters after the equal sign, right? And that's why I do this math. I do, hey, give me the entire length of the line, which is 66, minus the first 9 characters, and that's going to give me this how many characters. There you go. This makes more sense. I've done it justice. I hope that made sense. If it didn't make sense, it's impossible. I explained it. But I don't know what else to tell you. But anyways, we still have a problem. If I go ahead and press play, we're going to see variable and value. Both of them are going to appear, right? But so this is my variable. This is my value. Look at the value has the equal sign. It includes the equal sign. I don't want the equal sign. So it's simply, just do count plus 1. right? So if I do count plus 1, you will see that I have now my variable, and I have my make sure this works. Why are you doing? There you go. Now I have my variable and I have my value, right? They're both in two different strings, and I can prove that to you, and I can say, hey, my variable is called std that. I can say my value is, right, and if I press play, you will see you will see here that says my variable is called tilesheet and my value is this. So we've successfully split this part and this part, right? There you go. That's substring. That's manipulating strings and working with strings. It's cool. It's fascinating. It's awesome. It's great. Right? All right. I'm going to end the stream over here because I am in a lot of pain. I need to take some ibuprofen and go to bed because it's 12 a.m. 12:25. And we've been streaming for, drum rolls, please, 2 hours and 6 minutes. I think that's long enough. All right, cool. We are going to continue this next class. We're gonna parse the entire file, right, and extract our data. And then we're gonna use our data to load the map on the screen rather than having everything hard-coded over here. Or do I have it hard-coded over here? Rather than having the map hard-coded here, the map will be in the file and we load the file. Cool. I hope you enjoyed the stream. Again, I'm really sorry for taking 2.5 months to stream. I promise the next stream will be this week. It wouldn't take 2.5 months. Hope by then my jaw is okay and not in deep pain. And yeah, guys, thank you for coming, and I will see you guys next stream. Take care. Bye-bye. Do me a favor, subscribe button would be great. Liking the video would be immensely appreciated. And yeah, take care. See ya. Sayonara.